Doing good. How
Hey,
are
How are you
you?
doing,
Stefan.
Dan? Yes, hi. I was trying to talk to you, but apparently I couldn't unmute myself. So until you did. So I did,
Eh,
hey, hello.
That's awesome. So I will try to mute you to see if that how that works because I never did it before.
Okay.
So I'm not trying to be rude. I'm just trying to
No, no,
learn
no,
the
no,
buttons.
don't worry about it. Go ahead.
Okay, and I think that we are good to start, right?
I think we do. We gave five
Great.
minutes. I think that is more than enough. And I think we're sending the recording after the fact, right,
Of course,
Mital?
yeah. Mm-hmm.
Then yeah, let's start. So fixing bugs 5 times faster. So this is not really aimed to be a webinar. It's really something that we are starting doing right now, and that is to have these training sessions on a regular intervals, so people can just join, and they really supposed to be much more deep dive, and as you can see, much more relaxed. So if you haven't know me already, I'm Idan Schatz. I'm the developer advocate here at Ozcode. And in Ozcode, we are redefining debugging. And we have two products, the Visual Studio extension and the production debugger. And you guess it, this session is more about production debugger. We would have different training sessions on different topics. This time we will really focus on Tracepoint and what is dynamic logging, contextual data in integrations. And really the goal is to make you the 5 time debugger. Now, I have to say several things about the 5 time debugger. I didn't choose the title of this webinar. Our great marketing team did it. And then I was like, how the heck do I explain this 5 time debugger? Now, please join with me. It's going to be fun. So, where that come from? So we have this slide usually when we trying to explain that if you have hard time debugging production, you're not alone. But I couldn't find any number that would actually fit 5 times. So I needed to do something different to explain where the 5 times debugger coming from. Um, it's really that we really believe that you will be able to cut 80% of the time of debugging and solving production issues. That is where it really came from. But I have another way to explain it, and that is the 5 stages of grief or debugging. So really, when it's come to the solve any bug, if it's local or in production, there is several things that you need to do in order to fix it. You need to capture it. So be aware that bug happened once at least, and then you start the puzzle of reproducing. Right? Usually, you get an email from a client. Now you need to figure it out. We have a lot of clients that in order to reproduce, sometimes they need to get data from the client, sometimes like a dump of databases because it's a very database heavy applications. And that could be a very long time. And then after you produce it, you need to understand it. And that is also usually involve sitting in front of the debugger and press F10, 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 F10. And then you fix it. This is what you're paid for. This is where the fun part. And after you fix it, it's really bad if you don't have a way to validate it, because then it could happen again. So create a unit test or something like that, or make sure that that specific issue doesn't reappear again. And with production debugger, I really believe that you can ignore almost all of them, because if you use our tool correctly, um, you will be able to save tons of time of capturing, reproducing, understanding, and also validating that issue. And we will chat a little bit about that and how we're going to do that. So here is my explanation why 5 times faster. I'm not sure if you guys buying it or not, but it doesn't really matter because it's training time. So let's go to the production debugger. Now, it could be that some people here never saw this application in before. So I would actually spend a little bit time before we actually get into the trace points, which is the meat of this webinar. And we will basically start from the beginning, and that is adding an application. Um, And that is basically the first step. Like if you log in for the first time, this is usually what you see, create an application. It could be weird. What do you mean by application? But what we really mean is like a debugging environment. What we really now recommend to user is to have like one application for QA, one application for staging, and one for production. And of course, one for demo in the training. Awesome. Um, and here you will be able to choose how do you want to install. We work a lot to make this the easiest experience ever. And now there is this new UI that you just need to download for Windows VM. I think it's now the easiest. You just need to download the installer. The installer would have all the configuration, no more copy tokens and things like that. But you can actually choose it on different environment like a Linux. And here you will see in a bit a short video if you need some help. But basically, just copy paste this piece of code into your Docker file and you up and running. No need to change your code. No need to change build settings or connect to GitHub and stuff like that. It will just work. Um, so after we cover that, the first thing that I want to demo is an example with microservices and running on Docker and really resolve a bug and really to show you how to effectively use Tracepoints. But if you have never seen the product before, this is the error dashboard. And you can see here the agent would, after you install the agent on your application, you will get those exceptions captured automatically for you. And I will not talk about this today. That will be maybe the second time that we will do this training. We will focus more about solving bugs with exceptions. What we actually do is to really to solve the more gentle things, the things that are not ended in exceptions. And that is the trace point sessions. Now, what is a trace point? Another way to say it is non-breaking breakpoint, which means we allow you to add breakpoints into your running application. And in this example, we would have these night school course scheduling, and we have several courses here, and we can go and schedule, and there is some algorithm that's running that find the right rooms for this course. That basically the premise of what we're going to debug today. And this system is running on several containers. So there is microservices that go and talk to each other, and there is all kind of cool things that happen here. And what we really try to schedule here is that as soon as we go and start scheduling, those two will actually cause an exception. So we're not interested in them. And we schedule this one, there is some problem. Now, luckily for us, we actually created, we stream all the Docker, sorry about that. We are streaming all the Docker information to SEC, which is a pretty cool logging aggregation. And now you can try to figure out what the hell is going on. The only thing that we can actually see here, there is a warning, failed to find a room. And we know that is in resolve schedule, and we failed to do it. But that is basically it. And this is really the problem of trying to understand things with logs, because it's really far apart from what we as a developers used to do. And that is look at code and figure things out. Here, you really need to go and filter things. And that is very, very hard. We have a hint that something is bad happened, and that is in resolve schedule. So let's do a playthrough of how can we actually understand what is going on here. We will go back to the production debugger, and we will start a new debugging session. solving the bug 5 times faster. Oh, the 5 times killing me. So um, the first thing that we want to do, we want to figure out this resolve schedule issue, because um, this is where we found our bug. So let's type resolve. That might take longer than I expected. Then that query took a long time. So let's do courses controller. Awesome. Because I already know that this actually is in this course controller. Now, what the heck happened here? When I search here, let's just search for rooms, because that would be the second search. You see there is all kind of symbols here, where they're coming from, how this code came out to be if I didn't do any GitHub integrations and stuff like that. Well, the agent is smart enough to actually create an index of all the symbols that are loaded into the agents. And when you search here, it would actually search for all the loaded symbols in the agents that are connected to your application after you install the agent, of course. And as soon as we found this course controller symbol, it would actually decompile that class and show it to you. So you get the actual running code in production without any setup, which I think the team here did a really amazing job of getting to this ease of use. And in few weeks, you will even get a better code browsing experience, and you won't, this is trying to mimic the control T in Visual Studio. It would actually have all the modules loaded, and you can see a full tree, and you can just go and navigate the code that way as well. Now, we know that we have a problem here with some schedule. So I would add a new trace points. Now, it's tell me to write a message. Now, unlike other logging, it doesn't really matter what the message here. You can do whatever you want, and we will do it. We have a new schedule for course. And if I go a little bit up, you see there is this ID of the course. So I can use any local variables in curly brackets and add it as a structural log. And as you can see here, a new trace point has been created, and we can do start collecting. So if I will go back here and I will run this again, and let's go back here, you can see that we already have a new trace point in our dashboard. Now, like I mentioned, a trace point is a non-breaking breakpoint. So you can put as much as you want, and it will not affect, it will not pause your production system. The cost of it is basically like adding a log, like in Sarilog and things like that, but it's actually capture much more information. So as you can see here, like any structural log, you can actually see the arguments that we're throwing here, but here you can actually see much more information. And that is all the local variables for that specific function. And that really allow you to then investigate. Well, let's look at what happened. So we see here, there is lecture rooms and practice rooms, things looks okay here. And if we run the example that didn't work, go back, we can see a new trace point appear at the top for flight 001. And here, the new schedule, we can see there is no lecture rooms. So let's go figure out what is going on. So there is find available rooms method. So actually, I need to search again for, actually, no, let's do the rooms controller first. There is find available rooms. So maybe the problem was that there was no rooms available. That could be an issue. So now I go to rooms controller, and that is in service B. And I see here there is this available rooms. So there is throw new exception. So let's put no rooms found. But I also would like to put something here. We did found rooms. And let's just put this one with features and a list of features. Awesome. So let's put breakpoint that. Now, because we are already recording, those trace points actually get added automatically as I type. So now if I would just go do another one, you can actually now see that we found rooms. We have them twice with different features because probably that is the criteria that required for this course. So that is another thing that we really recommend how to work with it is don't try to think in advance of what you need. Just go add those trace points on the fly to really figure out exactly what you need to do. Now, we can actually see here that we have rooms and there is 12 and 3. So it's really interesting why we didn't really find those rooms. So I think we actually need to dig deeper into that function. So let's go back to the course controller again. And here, find available rooms. So we got some rooms and oh, you remember the log line in sec that we found? I think it was coming from here. So now let's put a breakpoint here. So what's up? And again, I just put that breakpoint, the trace point, and I don't really care what I need to log. Like, do I need to log what was available or what is it? I don't care. I just put that trace point here, go back here, and let's run it again. And now we can see, so what's up? That is exactly the message that we wanted. And now let's figure out what is really going on here. So we have available lecture room. Maybe that was empty, but we can actually see it have 12 rooms, which is interesting. And if I look at the first room, I see that maybe the problem is in the features, what the features that they actually wanted. They wanted VR and static field, so that seems to be legit. And there is another argument here, desired room capacity, that is get calculated somehow, and that is 20. So if we go look back at the rooms here, we can see the max capacity is 10, and that is basically the bug that we have here. That we wanted room with 20 people or 20 spaces, and we only have 10. So we didn't choose any room, and that why the schedule was bad. Now, to think about what we did here, the bug is not really amazing, but to think what we did here is, it is, because we actually had Tracepoint in a production system that is running in several services. And we actually collected Tracepoint from 2 different services. And when we're done with it, we can just hit the pause button and done, and that's it. Like there is no more. All those trace points are now being removed from the code. So it's not like normal logs that you first need to decide where you want to put them in advance because you insert them into the code, and then you need to deploy a new version of that code to do it. And if you didn't capture right information, well, that cycles go over and over again. What we try to do here is to solve those 2 issues at the same time, which is the first, those things are dynamic trace points or dynamic slogs. And you will see why we call them dynamic slog in a bit. But also, we capture all the local variables. So you don't really care what you don't need to think about what you need. You can then do it after the facts. Now, the problem sometimes is to understand if you have a lot of users using your system, you're at a trace point and several trace points, and now you have a lot of them, and it's hard to know which trace point or which log messages is actually related to which. Now, Ozcode come for the rescue here as well by default. And the first thing that I will show you guys is this correlation ID from Ozcode. And let me just put this one here. So here you can see there is several of them, and I will just choose one that have 4. And you can see several interesting things here. So you see here that we found the rooms, then we have the WhatsApp, then we have found another room. Let me just highlight that by adding the service name as well. So you can see here that this message came from service B because we found some rooms, and then service A said WhatsApp, service B sent search for another 3 rooms, and then we have the new schedule. Now, where does correlation ID come from, and how the heck correlation ID know that a message that was processed in a different service actually related? And that is part of what is called distributed tracing. And that is a bonus that you get as soon as you just install the Ozcode agent on your machine. Now, it's usually work with standard HTTP request and ASP.NET Core at the moment out of the box, but we will show you how you can do even more cool things down the line. And it would actually inject this correlation identifier to every HTTP request. So all the other HTTP requests could be then correlated at the same thing. Now, this is something that Ozcode do for you out of the box, but sometimes there is other services that already do that. And now let's chat about that. And the first thing that I want to show you, actually, that would be the second thing that I want to show you. So I didn't plan my lecture so well. Sorry about that. We will go back to this correlation IDs in a few seconds. But first thing, I want to show you something about sec. And let's just go refresh here. And you can see something interesting. So WhatsApp is here. How that came to be. And that is another very powerful thing that you can do with Tracepoint. And that is actually not just collect them and see them and analyze them. In Ozcode, you can actually then stream them to any logging services that you want. And let me show you how that get done. It's actually extremely simple. For example, or in this Docker example, we are using Serilog. So I would just open that. And let's go to the program of one of them. So here you can see there is let's delete those because they're just confusing. So here we can see we have set a Serilog logger, and we also write to file, of course, because we always need to write to file, write to the console. And also we write to sec server that actually aggregate all the logs. So usually you will find in your code, if you use logging in one way or another, this boot of logging. Now, you will need to install, in order to convert Tracepoint into dynamic logs, you will need to install our NuGet package that will then give you this Ozcode.client. And with the latest version, you have on Tracepoint hit, Ozcode integration on Tracepoint hit, and you can register an integration with the agent. What that is all about? Well, what that thing does is when a Tracepoint get captured and been recorded on our server, we would actually then send you an event that you can process after the fact. So this function will not slow your program. And you can then do whatever you want with the information that was collected by the Tracepoint. Right, currently, almost all the information, and we will chat a little about that. And then basically we use this Tracepoint enricher that add more information, and we basically just write a new log message with the message template. Now, let's have a deep look of what this Tracepoint enricher does. Again, this is code that you need to add to your application, so you can do whatever you want. We can provide you with those examples down the line. But basically, this is a normal Serilog enricher function. And as you can see, we are going over all the message properties and add them. We are going to add all the contextual data, and we're going to everything that related to the trace points, and we will see it in a minute. The trace point hit URL, the timestamp, the module, the class, all. And by we this type of information in in this example, the context. So I need to expand all. So you can see here the correlation ID. So I can do just find that. And now I can see the same thing that we did in and will take you to that specific whatever you want to investigate. And with that, I will just pause for a minute to see if you guys have any questions with the demo so far. Okay, great question, Michael. What happened to Ozcode integrations, and what happened if Ozcode is disabled? And actually, I would hope if we have a little bit more time to really dive into the performance implications of dynamic versus static logs. I think that is a fascinating topic. But just to like everything with the Ozcode package. So if I go to program here, and you see here this line register, if the agent is not loaded for several reasons, you disable .NET profiling, or it wasn't, it's not even installed on the machine, or all kinds of reasons, the package itself is an empty implementation. So if you don't pick our implementation of the NuGet package, you will see that most of the functions are empty functions. So basically, nope, there is no cost whatsoever if the Ozcode agent is not installed, and this specific code will never be executed. That is also same true when we will talk about contextual data, tracking other things. If the Ozcode is not there, there is no cost. Basically, or the call of calling an empty function, I would say. Any more questions? Awesome. So with that, let's go to actually do even more cool things. And that is, I will not really go deep into that. I will just show you the same thing in Datadog as well. So if you have Datadog, the cool thing about Datadog is that you can actually collect a lot of logs, and they have all kinds of very cool features to actually do a lot of things for you. And one of them is this distributed tracing. And by just creating those trace points, just streaming into the logs, they would automatically get into your Datadog environment. And then if I just look at a specific log line, you can see here all the context as well, all the information about the trace point. Here it's even easier because you can just click the link and it will open in Ozcode. But Datadog have really cool feature called trace, which basically take, it's something called the DD span IDs. They use some different tracking mechanism, I would say, but, or different tracking headers into your code. And you can actually get this beautiful diagram of this was the main request, and it sent the request to different things. And that log message that we actually injected ourselves happened in that specific time. So that is pretty cool things. But then again, how do we integrate with other systems that do other way to track the operations? Ozcode by itself will create this correlation ID number for you. And the rest of the example would be, I would like to think that is the right tab. I really hope. Yeah, almost. We will get into that. We will actually talk about application insights. And let me just go back to this application insight. And we would look at performance. So here it's a very cool, another good tool from Microsoft to give us deeper insight of how our system behave in terms of performance. And if I go here to this, let's say basket index, and I want to understand what is going on, or I want to go down, I can actually see the 8 samples that actually generate that and go and see the exact timeline. This timeline is actually pretty boring, but what I really want to show you is this thing here, this operation ID, and how that came to be. So this is another Microsoft thing. So Microsoft creates something very cool, and I would actually need to look at this activity tracking middleware that I just added to this application to really do this awesome integration that I'm about to show you between application insights and Ozcode production debugger. Now, application insight would actually inject to every HTTP request the system diagnostic activity that would basically represent the current activity or transaction. And this is supported distributed tracing. So this would actually go to different services as well using HTTP headers and database request. Microsoft put a lot of effort to inject it into almost everything. So this is pretty cool. Sorry, there is a message from Michael that Azure site section is broken. I would have a look about it in a minute. Thank you, Michael, for that message. So what we can see here is we actually get if we have an activity, and then we use, again, the NuGet package that we have for Ozcode to set the context and to set the tag trace ID and span ID, taking from this activity. And what that gives us, it gives us several cool features out of the box. I will go back to the tracing point in the middle, but I just want to show you that is also in the errors that you can see here. You can see the trace ID for that error. So if an exception was, so if you capture the exception using Ozcode, you can now copy paste this value and search it in application insights and see exactly what happened in that specific moment. Now, you can even do more, and I would actually now need to jump to a different demo. And here there is another Ozcode application integration. And this time, we, instead of sending the Tracepoint hits into Serilog, we now use the telemetry clients of application insight, if you're familiar with that, and we actually inject this as a as a as an event into application insights. And what that allows us to do, and let's just jump into a different demo, because I think this demo is extremely cool. Web app on Azure, and we will go back to Tracepoints. And I think with that, we would actually then start to answer more questions that people have. And I have a session here. And in this example, we are going to use this issue open web. And most of you saw this demo already. And we just go update the basket and see how the price goes up and down. And our shareholders want to know if someone make a very big purchase. So what we added into the code in order to try to understand that is when we actually update the basket, we ask the basket, give me the total. And if the total is 100, then larger than 1,000, then we use application insight to track an event. Oh, there was some high detail. The problem is that we didn't really find a lot of events like that. So we think there is might be a problem. So we actually put a trace point exactly after we get the total number, the total amount in the basket. And if we will start to record that and go back here and do 6, we can go back here and you can see that we actually collecting how much that was being collected. Now, the cool thing around it, if we just go back to these trace points, oh, the basket is total and I don't do the buyer ID. That is too bad. Let's look at that. I think it's here yeah, it's basket model buyer ID. So we will just go and change this for basket model buyer ID, and hopefully I got that correctly. So let's change that to 10 and go back here, and you can see we actually get those right values. And let's just change a little bit more, update and 80 and update. And I hope that, yeah, now we get really high value. So if I would actually go to the tracking here, and I can see the transaction search. That's supposed to be here. Usually there is a few minutes delay that that happens. So I don't think we would actually get all the requests that I'm expecting here. But due to lack of time, I will just ignore, move forward. But what you can actually do, and let's just go back here, you can then trace your, you can then ask the application insight to get all the traces that have been recorded at telemetry client. And you can see here, this is all the trace, and you can see that this is the message that we wrote, and this is all the custom dimensions that we injected. So you can see the machine, you can even see the tracepoint URL, so you can see the tracepoint that actually created this message. And also what we can see here is, I'm not sure if I have, do I have a buyer ID here? I don't think that we have a buyer ID in this example. I'm not sure those messages came already, but that can really be used to actually create graphs out of that. So we would actually do line, and we want to use the basket total, which, as you can see here, it's a feature that we extracted from the trace message. And we don't want to split it by message. We want to do it by buyer ID. But in this example, we didn't really provide the buyer ID. And you can actually see how the prices of the basket changed over time. So another cool example of how you can use Tracepoint and dynamic logging to really investigate phenomena that you couldn't see before. And with that, I think that really solve and what I want to show you guys today. So I would really be happy to just open it for questions. You can use the Slack, you can raise the hand and I will let you speak, or you can use the Q&A. In the meantime, I would actually see if we actually get the latest message. I did something wrong. So let's see what happened here.
So I see we have in the meantime a question from Michael.
Okay.
Is there an example of using the Nudge package for logging insight available?
We are working on having that like public, but Michael would just send you the code snippet that I show you here at the moment, and it will be available in GitHub down the line. So so that is a different, and Now the total, and I think that was 2 number, but I'm not really sure how they say it too. I'm not really sure how did they do that, but 2 number, 2 double. Yeah, 2 double works. Yeah, cool. So now we have all the events. So now we can create graph out of that. Stefan asked, after adding all those trace point in production debugger, how do I continue with the normal code? What do you mean by normal code? And let me try to find you so you can maybe already executed code. I'm not sure that I really understand what you're asking, so I will try to do my best and let me know if I actually answer the right question for you. So when you hit a trace point, you can actually, a trace point hits, you will see all the local variables and the code for that specific function. If you click here on the trace point definition, you will actually get the code of that entire class, and then it would allow you to add trace points. Now, clicking here, it does allow you to, so you can add trace point here as well. Okay, so you want really to go to find that in your source code, Stefan? I give you permission to speak as well. If you can help me guide, if you can guide me to what you want to ask. But of course, technology. So I think what, if I just try to understand what you're asking is, how do you go to the regional assemblies? How you revert back all the trace points that you added? Maybe that is the question. Awesome. So as soon as I play start recording, all those instrumentation happen in real time to all those functions. As soon as I pause, it's go back to the original assembly to execute the same code that you have. Let me just dive deeper of how this magic actually happen. And that is the difference between static and dynamic logging. So when we have a function in C#, when it gets actually compiled, it's compiled to IL bytecode. So there is some method metadata data and the bytecode that get then executed to runtime. When you by yourself at the logging message, basically it will just inject some more bytecode that will create the message, serialize all the variables and things like that. Now, what Ozcode does behind the scene is we take the bytecode and use a decompiler to extract the code itself. And with a semantic understanding of that code, when you add a trace point, what actually happened, we add for you something similar to a logger message, same effects, which basically then by doing bytecode manipulation, which that technique is not new, but the way we're using it, I think it's novel. It's basically adds the same thing as you would add log line in your own code. Now, the cool thing, because we're using the .NET Profiling API, we can actually use Regit to go back exactly to the original code. So as soon as you go and hit the pause button here, you just get the original performance, no performance penalty whatsoever. And again, the cost of a trace point is equivalent to a log line. Does that answer your question, Stefan? How do I mark this as answered? Oh, you can do dismiss. Awesome. So it took me like 4 tries, but I finally understood what you want me to, what you asked. So thank you for your patience. No worries. So while more people looking for questions, we'll just go and continue rant about dynamic list static logging. So please interrupt me if you have much more important questions you want to get answered. Now, the cool things about, I think the difference between static logging and dynamic logging is there is several things that I just don't like about static logging. And it's the same type of philosophy that if your code need comments, probably you didn't write good enough code in the first place. And the problem is comments that they get stale over time because the logic could change, but sometimes the comment didn't. And now the comment that was helpful, now it's just even more confusing. And also it's polluting your code. And same thing is for logs. You try to debug something, so you had ton line of log lines, and now it's really hard to understand what the function is already doing because there is tons of log lines. And if you use log lines, then you now need to make sure they are not stale, which is another problem. And also you can have side effects with logs because um, what happens if you're trying to log with structural log, you're trying to log a very big uh, structure or a numerator or something like that. That could actually start evaluating the numerator just because you added a line of log. And sometimes the logic, just because you log something, actually change it. And with dynamic logs, because we are adding the logs dynamically, the Ozcode production debugger can do several cool things for you automatically. And several things. First, there is no code changes, so you can add them and remove them on the fly, and it doesn't really pollute your code. You can actually save your debugging sessions and then disable them and enable them when you need them. So you don't really pay the price of static logs, keep recording and recording things. You only record when you want them. Another cool thing is the side effect free. When we capturing local variables, and that is true for exceptions and trace points, we do a lot of checks to make sure that we are not modifying the state of the program while capturing it, which basically mean we only capture fields and auto properties. We don't capture properties that actually can modify the object itself. So that is another cool thing that you get out of the box for free. And also, if there is a large collections, we would actually limit the number of items that we serialize. So again, not to avoid memory pressure and network pressure of actually recording those things. And yeah, so not sure if you guys have more questions. That is so funny. Like, uh, the quiet is very hard for me. Is this also work for a desktop app? Yes, it does. So let's go back to the install agent tab. So you can have several things. If you go my host, Windows, desktop and Windows applications, um, there is some step that you need to do. And if you open the instructions, the only thing that you need to do for desktop app is first you need to install the agent on the machine that's running the desktop application. So for QA environment, that is pretty easy to do. And the last thing that you need to do, and it doesn't really say here. I think it would actually open here. La 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 la. Yeah, you need to in this step specify the name of the executable that you want the agent to attach to. The agent will not attach to all your processes because you just install it. You need to specify what the name of the desktop application, and you get everything for free then by that point. Exceptions, even swallowed exceptions in UI would be captured, and you can do trace points. And another thing that I think Michael asked about, this one that is broken, I'm not really sure about that, but I just, for Azure App Services, the installing agent is pretty easy. You just need to go and set this token and into the configuration and add the Ozcode production site extension, and that's it. It works seamlessly if you have also application insight on that app service. You will need to add the middleware to make all the magic work, but that's basically it. Thank you, Stefan, for all the questions. I really, really appreciate that. Yeah, Dem, I think, no, sorry, Denise, I think I gave you permission to speak. I think so.
All right. Can
Hey.
you hear me? Okay.
Yes.
All right. So the biggest problem we have in our environment is security.
Yep.
So if we leave these agents running, can anyone intercept those things and, have, because those are questions we kind of have to answer before.
Oh yeah, totally. That is a
the
great
due
question to
diligence
ask.
process. Mhm.
And I will just need to find the right slide that actually talk about that. So in terms of security, there is two main features here that are that are important. One is what the agent actually does to protect the security. And there is full encryption between the agent and the server, and also PII reduction. We didn't talk about this in this training, but reducing sensitive information to protect your privacy of the clients. Also, you get out of the box. Now, in terms of security and have different type of regulations, what you really can do is you can install the server on-prem or in your cloud, secure cloud environment. So then all the communication between the agent and the server is inside your network and nobody can access it from remote locations. Is that answer your question, Dennis?
I think the question I'm asking is, what does that prevention? Are we just relying on our own firewalls, or is it a feature that you have that restricts that communication?
Oh, and then I think it's the agent itself. You can't really talk to the agent itself. The agent doesn't accept any, doesn't open any new ports and stuff like that. All the communication is outgoing from the agent, and it will talk to the server. So if your agent is in a secure location and you install the Ozcode production debugger server, which is a different software unit in your private network, then there is no communication go out of your network. And you can run this thing in networks that are secure in terms of like government agencies and other type of secure facilities. You can run it with network that is not even connected to the internet, and you can also have it based on your security and firewalls, but there is no need to any firewalls rules in my understanding. Am I answering your question now, or you want to dive into that deeper?
I don't mean to take up too much of your time. Because I'll have to answer these questions at some point.
Okay.
I can take it offline if it's taking too much time, because I know you also have a limited window. I can be
so
more specific
I
later.
think I can actually, I would reach out to you with a private email after this, and
Sounds
we
good.
can sit deeper into more details, and I can provide you more information about securities.
All right. Thank you so much.
Reduction of those kind of things. Thank you. So my application code is altered in memory, so by inserting new calls. If I understand, your code is only dumping data, and it will allow to, it's also allowed to alter data. So that is a great question. No, you can't really alter the data. It will just dump the data, and we work very hard of not changing the state of your code. So by adding a trace point, you should not see any effect of any change in the logic of your application. Mark, let me know if that answers your question. And Andre, what about Windows Services apps? Okay. I think what you mean to ask is, can you monitor Windows services on your machine? And the answer is yes. It's basically follow the installation of a desktop application, and you can do that. Um, if you have some unique cases about permissions and environment variables, um, I can reach out to you to figure out if there is some issue around that, but it should just work. If doesn't matter if it's a desktop application like WinForms or Windows Service. Awesome. So now let's start delete the QA that we actually answer. Mark, did I answer your question? So I would not dismiss this one yet. Awesome. Any more questions? I can see the time, but yeah, I think we out of time for this session. So I would just give another 30 seconds if someone have the chance for the last question. And with that, I think we would end it for today. And I would like to thank you guys very much for spending this time with me. I hope it was beneficial, and that you can now go be 5 times developer, debugger, of solve bugs 5 times faster. Anyhow, I wish you all a great day or a great evening, depends where you are. And with that, I think we will call it a day. Take care, guys.